Janine Turgeon. Hello, my name is Janine Turgeon, and today we'll be looking at the molecule shown on the screen. This molecule is commonly known as bupivacaine, and it is an anesthetic that is used during childbirth, dental procedures, and some surgeries. Bupivacaine is administered as an injection. It numbs the area around the injection site by blocking signals at the nerve endings. The IUPAC name is 1-butyl-N-2,6-dimethylphenol piperidine 2-carboxamide. So let's look at this molecule and determine how we got this name. To begin with, we have 4 functional groups. First, on the left, we see we have an aromatic ring. And attached to the aromatic ring, we can see we have 2 methyl groups. Connecting this ring to the rest of the compound, we see we have a secondary amide. And then lastly, there's a tertiary amine in the other carbon ring. Next, we need to determine the highest priority functional group, which in this case is the amide. So we place this at the end, calling it carboxamide. Then we determine that this is the parent chain, which in this case is called piperidine. And when we label this ring, we can see that the amide is connected on the second carbon of the chain, or the second labeled molecule. So this gives us piperidine 2-carboxamide. Then we'll take the rest of the attached substituents and functional groups and label them alphabetically and making sure to have the lowest number for the attachments. So we have a butane attached to the number 1, which will give us 1-butyl. Then we have 2 methyl groups attached to carbons 2 and 6 on the aromatic ring, so we get 2,6-dimethylphenol. And then to indicate that the aromatic ring is attached directly to a carbon, we add an N. This gives us 1-butyl-N-2,6-dimethylphenol piperidine 2-carboxamide. Now that we have the name, we want to determine the chirality of the compound. So we're going to look at the compound and see if there's any atom that is attached to 4 different groups. In this case, we can only see one atom, the second carbon. So we have one group here, a second group, a third group, and then we also have a hydrogen bond, making it a 4th group, which makes this a chiral center and a chiral molecule. Then we want to determine the configuration of this molecule, if it's R or S configuration. So we're going to look at this wedge and dash model and determine the priority of the attached groups. So hydrogen is going to be the number 4th priority, or the lowest priority, because it has the lowest atomic number. And then nitrogen is going to be the number 1 priority, the attached nitrogen, because it has the highest atomic number, so it's the most important. Then we have 2 attached carbons, and to determine which is higher priority, we're going to look at the other connections. So the other connection, or the next connection, is another carbon. And then in this one, the next connection is an oxygen and a nitrogen. And oxygen and nitrogen both have a higher atomic number than carbon, which means that this attached carbon is going to be the 2nd highest priority, and this is going to be the 3rd highest priority. Then we can take these priorities and draw an arrow from 1 to 3, and we can see that it's clockwise. A clockwise arrow indicates that we have the R configuration for bupivacaine, means we have R bupivacaine. And since there's one chiral center here, we know that there's going to be 2 stereoisomers, which means there's going to be 2 enantiomers, since they come in pairs. This is one. Next, we want to find the S-bupivacaine, the other enantiomer. And we can do so by drawing a mirror line, or a line of symmetry, and mirroring this compound across the line. This gives us S-bupivacaine, and we can verify that by again drawing an arrow from priority 1 to priority 3. We can see that this arrow is counterclockwise, and that indicates that this is the S configuration. And so the R-bupivacaine configuration is also commonly called dextrobupivacaine. And the S configuration is commonly called levobupivacaine. And interestingly, levobupivacaine, when used as an anesthetic, it has a longer duration and causes less vasodilation than its counterpart dextrobupivacaine. So that concludes the video. Thank you for watching, and I hope you enjoyed